Hey everyone, welcome. If you're an aspiring pilot or just someone who really wants to deepen your knowledge of flying, you are definitely in the right seat today. As a flight instructor, my goal is to guide you step by step through one of the most vital organs of any aircraft, and that is the engine ignition system. In this explainer, we're going to look under the cowling and demystify the mechanical heartbeat of your plane. We'll take this all the way from basic mechanical theory right up to critical flight safety, just making sure you know exactly what's happening every single time you turn that key. So here's our flight plan for this explainer. We're going to cover 1. How ignition systems work, 2. The dual ignition advantage, 3. Magneto checks and failures, 4. The dangerous hot mag, and 5. Detonation versus pre-ignition. All right, let's dive right into section 1, how ignition systems actually work. I want you to think of the Magneto as a totally self-sustaining mini power plant. Its job is incredibly simple, but absolutely crucial. It supplies the electrical spark, which is the main ingredient for our fire. It does this by physically rotating a coil within a magnet to generate an electrical current. But here is the most important takeaway for any pilot. This current is completely 100% independent of the airplane's main electrical system. Once that engine is running, the Magneto does not need the aircraft battery to keep firing. Let's break down the logical chain reaction that happens every time you start the engine. First, you turn the ignition switch to start. That draws power from the battery to engage the starter with the flywheel. As the starter turns the flywheel, the crankshaft begins to rotate. Now, because most training aircraft are direct drive, that turning crankshaft spins the propeller, and simultaneously, through a set of gears, it spins the Magneto. The Magneto generates the spark, and boom, the power stroke, intake, compression, power exhaust begins. And the beautiful part? It just keeps operating as long as that crankshaft is turning. In fact, if you had an in-flight engine failure, as long as the relative wind keeps your propeller windmilling, the Magneto will keep generating a spark. You wouldn't even need to turn the switch back to start. Moving right along to section 2, the dual ignition advantage. Think about this for a second. Your car generally has just one ignition system, and it works perfectly fine, right? So why does aviation mandate that we have a dual ignition system? We're talking 2 completely individual magnetos, separate sets of wires, separate spark plugs, the whole shebang. Why? Well, the simple answer is that 2 is always better than 1 in aviation, mostly for a couple of key reasons. First up is performance. Each magneto operates completely independently to fire one of the 2 spark plugs located in every single cylinder. Having 2 sparks firing at the exact same time across the cylinder vastly improves the combustion of the fuel and air mixture, which actually gives you a slightly higher power output. Second, and honestly most importantly, is redundancy. If you're flying along and one magneto or one set of spark plugs completely fails, the other one is totally unaffected. The engine is going to continue to operate normally, you'll just notice a slight decrease in engine power. Okay, section 3, Magneto checks and failures. During your pre-takeoff checklist, you know you have to move the ignition switch from both to left and then right to observe the RPM drop. The acceptable drop range is going to be listed in your pilot's operating handbook. But what if you switch to the left mag and notice this massive RPM drop, or the engine starts running violently rough? Well, that usually points to fouled plugs. A fouled plug basically means there's a stubborn carbon deposit sitting right on the spark plug, blocking it from supplying that vital electrical spark. This is almost always caused by operating the airplane with the mixture controls set way too rich. All that unburned fuel just leaves a thick carbon deposit right on the spark gap. Now, if you do encounter a fouled plug, don't cancel the flight just yet. There's a pretty standard troubleshooting procedure for this. First, switch the ignition back to both so the engine runs smoothly again. Next, lean out that mixture control and push the engine power up to 2300 RPM or more for just a few seconds. The excessively hot temperatures generated by this lean, high-power setting will literally burn that carbon deposit right off the spark plug. After a few seconds, pull the power back to your normal run-up setting and check those magnetos again. 9/10 out of 10, the plug is clean and you are totally good to go. But let's look at a couple of the scarier scenarios. You switch to the left magneto and the engine completely stops. Well, that means your right magneto, the one that was supposed to keep you running when you turned the left one off, is already dead. You need to taxi right back to the ramp and call maintenance. But what if you switch the magneto and there is absolutely 0 drop in RPM? No drop at all? Actually, before we solve that no drop mystery on the ground, I need to throw in a brilliant real-world cockpit reality for anyone stepping up to complex aircraft like the Piper Arrow. In flight, if a magneto fails on an aircraft with a constant speed propeller, your RPM gauge is not going to change. The propeller governor will automatically adjust the blade pitch to maintain the RPM, completely hiding the failure. So, if you want to detect an in-flight magneto failure in these types of planes, you have to actively monitor your manifold pressure, or MP gauge, instead.
Which brings us to Section 4, the dangerously deceptive hot mag.
So, back to that ground check. The crucial point here is that a run-up check showing no RPM drop is not a sign that you have some super efficient engine. It's actually a massive ground safety hazard known as a hot mag. If you switch to the left magneto and there's no drop, and then switch to the right magneto and there's still no drop, your magneto is hot. This means the ground wire, which mechanics often call the P-lead, between the magneto and the switch is either disconnected or broken. And because of this broken wire, the magneto literally cannot be turned off. It is always live and ready to fire no matter where your ignition key is pointing. If you ever determine you have a hot mag during a run-up, you must immediately return to the ramp, shut the aircraft down, request maintenance, and prominently write hot mag on the windshield. Why the big warning sign? Because a hot mag can lead to fatal injuries on the ramp. Think about it. If the ignition switch is totally off, but that ground wire is broken, and a student pilot or a mechanic lightly pulls the propeller by hand just to move the plane, that slight rotation of the crankshaft spins the magneto. The magneto generates a spark, and the engine could accidentally start up right then and there. So please never take a no-drop check lightly.
And finally, Section 5, detonation versus pre-ignition.
Examiners absolutely love testing the difference between these two concepts on check rides, so let's break them down. In normal combustion, the fuel and air mixture burns smoothly and predictably, radiating outward from the spark plug. But in detonation, the mixture doesn't burn. It explodes uncontrollably, all at once. This violent explosion causes massive temperature and pressure spikes that can literally blow a hole right through a piston. Pre-ignition, on the other hand, is a timing issue. It means the mixture is igniting way prior to the normal spark event, usually because there is a glowing hotspot or a carbon deposit sitting inside the cylinder, lighting the fuel up way too early. Detonation completely ruins the precision of the four-stroke cycle, but what actually causes it? While using a lower fuel grade than specified by the manufacturer is the biggest culprit. Low-grade fuel combusts at a lower temperature, so it simply cannot resist the extreme heat of full compression inside the cylinder. It just detonates before the piston even reaches the top. Other causes can include operating with extremely high manifold pressure but low RPM, running an excessively lean mixture at high power settings, or even extended ground operations, where you're sitting on the tarmac and there simply isn't enough ram air flowing into the cowling to cool the engine down.
The absolute best way to prevent catastrophic detonation starts right at the fuel pump. You always have to ensure you are using the proper grade of fuel. In aviation, fuel is dyed specific colors so you can visually confirm exactly what is going into your tanks. 100 octane fuel is green, and 100 low lead or 100 LL is blue. If you see a color you do not recognize during your pre-flight sump check, do not fly. Simple as that. Preventing pre-ignition, on the other hand, really comes down to managing your engine heat correctly. You want to avoid creating those glowing hot carbon spots inside the combustion chamber. You do this by, again, using the proper grade of fuel, operating the engine strictly within its proper temperature limits, which means managing your climb angles and airspeed to ensure you have enough cooling airflow, and keeping a close eye on your RPM and engine gauges. And remember to use enriched fuel mixtures to cool down the engine when your checklist calls for it. As we wrap up today's explainer, I want to leave you with a thought. We've learned that the magnetos is this beautifully independent, self-sustaining system that really doesn't need your battery at all to keep you flying. But that independence means it relies entirely on your diligence during the run-up check. If the magneto's lifeblood is entirely separate from everything else, how certain are you of its health before your next takeoff? Never treat your run-up checks as just a routine checklist item to rush through. You are acting as the mechanic, diagnosing the heartbeat of your aircraft before you trust it with your life. Keep learning, stay safe out there, and I will see you in the next explainer.